Okay, so we're going to start a new unit today, and the unit we're going to talk about today is quadratics. And the nice part about quadratics is we should remember quite a bit of this from the polynomial chapter. So if you remember from the polynomial chapter, a quadratic is a polynomial where the highest degree, or the degree of the polynomial, is 2. So then we got a couple examples of quadratics. This right here would be a quadratic function because its highest degree is degree 2. Same with this one over here because its highest degree is degree 2. This one, however, is not a quadratic because it has a degree 3. So its highest degree is degree 3. So it is not a quadratic. So the only focus that we're going to have in this entire section is we're going to focus on polynomials whose highest degree is degree 2. Now the nice part about quadratics is we can actually break quadratics down into a couple different things. So quadratics could have a degree 2 term. Since their highest term is degree 2, they could have one degree 2 term. They could also have a degree 1 term, which would be called a linear term. And they could have a degree 0 term, which we would call a constant. So this is kind of our degree 0, this is our degree 1, and this is our degree 2. So we can have these different terms, and we can kind of label these when we have quadratic equations. So I have this equation right here. And right off the bat, we're not quite sure if it's quadratic or not, because it's not really in standard form, or the x squared term leading, the x next, and the first or the constant term after that. So we're not quite sure what this all is. So before we move on, we're going to take this thing and we're going to kind of get it in a simpler form. So for me to get this in a simpler form, I'm going to take this x and distribute it here and here. And I'm going to take this negative sign and I'm going to distribute it here and distribute it here. When I do that, I should get x minus x squared minus 1 plus x squared. Now I'm going to start combining like terms. So I'm going to take my negative x squared and add it to my x squared, and a negative x squared and a positive x squared is going to give me 0 x squared. And then I'm going to have a positive x. I'm going to have a negative 1. So we can label these terms. This actually isn't a quadratic function because it technically has 0 x squareds. But we can say the quadratic term for this case is 0. The linear term for this case, or the number in front of the x, is 1 because we have 1x squared. And we're going to say the constant term, or the term that doesn't have an x with it, or degree 0, is going to be negative 1. So again, we can label all these three terms. So my 0 term, my 1, and my negative 1. In this second example, we're going to try to do the same thing. So when I look at this, I'm going to start out by saying, okay, let's try to make this simpler. So we're going to take this and multiply it by there, which should give me 6, and x times x will give me x squared plus 6. Now again, I'm going to look, and I have 6 for my quadratic term, because I have 6x squareds. I don't have a single linear term, because I have no x's, so that's going to be 0. And then my constant, well, I have, again, 6 for my constant term, because I have 6 things that have a degree 0. So that's how we decide what quadratic is, and the different terms a quadratic might have. It might have a quadratic, a linear, or a constant. It can't get any more because if it has a degree 3, it'd become a cubic function. So we're just going to look for the quadratic term, the linear term, and the constant term. So right now, what I'm going to have you guys do is go and try the 5 problems that have this idea where you're trying to find the quadratic term, the linear term, and the constant term.